Welcome to everybody. My name is Emil Wrzosek. I represent Crisis Information Center of Space Research Center of Polish Academy of Sciences. And today I will be hosting this training. Together with us is Panayotis Kollios, who will be providing the main part of the training, the part related to AI utilization. And he is also a coordinator of our ARTION project. We will start from presenting the event agenda. After the short introduction and presenting the results of the general seminar that we had a week ago, we will jump straight towards the training materials about the AI technologies for disaster management. This will consist of three main parts. An introduction that will highlight the usefulness of employment of AI for disaster management, but also the scientific background of this, and selected topics for AI on disaster management, in disaster management area, in civil protection area. So this will be where when the examples will be the most visible ones. The last part of this meeting will be about the testing and evaluating AI technologies. This may be somewhat useful for the participants that are interested in employing these tools, AI tools, machine learning tools and solutions, and in their own organizations, and they wish to went through the process of testing and trialing them in a more organized way. So at the beginning, I would like to shortly recap the project ARTION development so far and soon available studies. Starting from the ARTION vision, the vision is to become a network for knowledge sharing in the field of artificial intelligence for disaster management actors, and to somehow guide the development, of use of those AI tools by the first responders. We seek to equip civil protection experts with the data tools and expertise to better manage disasters and other challenges while stimulating further research into this field as well. The ARTION stands on 4 pillars, and those pillars are research and innovation, quantifiable field exercises, training and networking, and open knowledge. In the pillar of research and innovation, we are surveying the application of AI in disaster management in general, and the project also develops machine learning tools for key challenges that was identified during this survey. The result of this survey as a report can be accessed by our web portal. About the products, the first example of products developed and tested during the project is the aerial person detector, which can be used to help to detect, identify, and track individuals on footage captured from, for example, UAVs. And this is an algorithm that can be applied at real time. The other utilized and tested solution is a disaster detector and classifier that can detect fires, floods, and building disasters. It can work on, for example, UAV captured images. In the field of testing and trialing those solutions, we already conducted 3 exercises in Cyprus and 1 in Italy for collection for data collection, and 1 exercise in Cyprus for testing a mobile application and web platform for first responders. We are also planning exercise to test those machine learning algorithms in real time, so more will come. In the field of training and networking, we developed extensive training materials. These training materials in shortened form will be presented today. All of those materials are available online on our web portal. You can download them and use them in your own institution. Also, together with these materials, we developed a training, a tutor's book. It can be useful for the trainers' activities and help you to conduct the training by yourself. So as a trainer. We already carried out 2 national trainings and received a positive feedback. In the open knowledge pillar, we created a community at Zenodo repository with all those datasets that we mentioned. And also we have a portal, Disaster Management AI, download or read all the project results so far. As you can see, there is a lot of datasets already available, so it may be useful to visit and use it. And maybe I will do a short presentation for you, just as a proof that the portal is existing and running. As you can see, this is the main page. You can access it by the link that is at the end of the agenda that we sent to you. And also you can just type in your Google search engine ARTION project portal, and you will be sent here. In this portal, I'm sorry, the timing is a bit slow because I'm sharing the camera footage, so the broadband is pretty much smaller than usual. At this web page, you can see the basic information, the general information about the project. You can read about the consortium partners of the project. But also, as I said previously, you can check and read about our research and innovation activities, which also means that all the project reports are here. The training materials are available here to download them. You can take a shorter look by using this application here. And as I said, the training has also the trainer manual, so it may be useful for you if you wish to conduct the training on your own. Of course, during the project and after it, we will try to help if you request for such help. And in the last page, you can access the data. So the scenarios, the algorithms, manuals, and also links to datasets. Of course, there are other pages here, like the deliverables or news or contact. You can browse it. Getting back to the presentation, I would like to wrap up the previous week's seminar now. We had 4 presenting their own success stories. The first presenter was Dr. Ivanka Pelivan from Fraunhofer Institute, and she presented to us a focus group on AI for natural disaster management that is built to collect the data and to explore best practices in the area, and to enhance the communication between stakeholders and other practitioners in this field. This is very interesting process, and they collect the data. So if you are interested, you can join. Here you can see the link. The second presentation was given by Tomasz Motyl and Tomasz Niedzielski, which represent the high mountain search and rescue in Poland, and the SAR UAV application that is being used by this high mountain search and rescue. And this is a novel IT system that supports searches for lost person, and it's used mainly on UAVs. It helps to detect humans in this kind of images collected by UAVs. The drone flies over the terrain, collects nadir images at a flight level of about 60 up to 100 meters. It depends on the type of a drone, and collects the data that is then copied to the local computer and processed in a very fast time, like we see 100 images per 2-3 minutes. So it can be easily done on site. And SAR-UAV is used operationally from about a year right now, and it's already saved one human life in Poland, which depicts that it's a very useful tool, and maybe can be interesting also for you. The second presentation was, the third presentation was from Dr. Jakub Ryzenko. He is my colleague, and he spoke about airspace management for UAV operations, and an exercise that was conducted in Poland the third quarter of last year, during which the airspace management was trialed and achieved a success during this event, and during these big exercises we had a number of aircrafts, manned and unmanned, that flown over the terrain. During this event, we needed to introduce a segmentation of airspace. So it was vertical and horizontal segmentation. So there was a selected air volumes for each aircraft in which they can operate. For example, there was a situation when small drones was flying on the level of up to 50 meters, and the helicopters were operating between 100 and 150 meters. And above them, at about 300 meters, there was a big strategic observation drone. So we achieved 3 levels of segmentation, and also we have a few areas of segmentation in the same time. So this exercise was not very closely connected yet with AI systems, but allowed to set to find systematic gaps for those AI systems to be developed further. And we already started working on the system that can help in such airspace management tasks. And the last presentation of success story was about a living lab in Strandtumsite Street in the Netherlands. And it was the speaker was Tinus Kanters, the father of this idea. And this living lab consists of few systems that are based on AI and machine learning. They made a digital twin of a very busy street that is called Strandtumsite. and they monitor the activity of people on this street, and they count people on the street. They are listening, so they are sonic detectors on the street that are listening and analyzing what they hear, what the detectors hear, and based on those analyses, they alarm if they detect anything interesting from the point of view of emergency management. At the time they generally look for the signals of aggression or the signals of panic. And also they have a number of other tools, for example, a tool that can monitor the movement of cars, including detecting number plates and registering and detecting what is the color and model of the car, so it can be used, for example, by police if they are looking for a particular vehicle that was for example, stolen, but somebody switched the plates of it. So they can make a search in this way just by looking at the color and model. Currently, Living Up is working at this very busy street, but they are conducting some works to enlarge the area to the whole city. And finishing this introduction part, let's go through quickly ARTION activities conducted so far. So the already mentioned field exercises in Cyprus. The effects of those exercises can be seen on our web portal. For example, the scenarios of those exercises and the scenarios of those trials and data collected, and also the additional useful data, for example, the slime trials of the rescuers that are visible on the footage on the video footage, so you can use it to verify your own algorithms based on those data. As you can see, this is both of those types. On the left side, the videos captured by the drones, and on the right side, the GPS traces captured by the mobile apps. And also the usability and applicability review was conducted towards the tools that was provided in the project. For example, a tool to help the voluntary management. It was a mobile app and web platforms, and the aims of that tool was not only to collect data but also to facilitate the communication and information exchange between responders and emergency control center. And the tools were developed after a need that was identified during the first three exercises and already tested in one exercise. Also, we had a plan to participate in exercise Ben2S2 in Sardinia, Italy. The drones were expected to be used for hydraulical risk detection and assessment in a flooding event. However, the exercise was conducted on a smaller scale because of the alert, the COVID alert in the area. So we participated in another exercise on 18th of December. And during this exercise, drone was capturing the footage from a focal point where the volunteers were moving, and the idea was to test the radios and to check, also to provide the data for further tests. And following the track of work already done in the project, the review of existing AI tools can be accessed on our web page, and it highlights the areas that can be useful disaster management efforts, for example, early detection, search and rescue operation, damage and risk assessment, or operation planning. And it works as a gateway for further research. What is about to come are the end users oriented field tests, during which the usability and applicability review will be further done. In the following months, exercises will be conducted, and they will be hosted by Cyprus Civil Defense. And during those tests, the final version of the mobile app and web platform will be tested, and already developed algorithms will be used in their final form to analyze the footage captured by drones, and so we can discuss the effects with them, with the practitioners, and receive their feedback on the algorithms, the final version of algorithm. And also in July, we will be publishing open data and AI algorithms report. So just to state that it will be available soon, and it's worth to save our web portal and to check the web portal from time to time to look at the reports that we will be publishing. And if it comes to upcoming evaluation activities, we are going to publish a new needs and requirements report, and for this report we will be reaching towards you and other experts. We will put a survey, and would like you to ask you to participate in it. We will ask about your needs, the gaps that you may see, the systematic gaps, and maybe lessons learned during application of your own AI algorithms. And for the last time, if you are interested, please visit our knowledge portal.